Okay, so my last video was just a cautionary tale about when linear regression might be useful. So, the main way that people use linear regression is basically like on the data you have to make guesses about the data points that you don't have. So like a new person or subject where you know one of the variables but you don't know the other, or you're just trying to like make predictions about what would happen in the gaps that you're missing. And so one of the ways that people do linear regression is to put time on the x-axis. So you know the value of some variable at different points in time, and they kind of go in a line. So you sort of draw a line through it, and then that will let you predict into the times that you don't have. Now, those predictions, if the dots appear in a pretty good line, those predictions tend to be quite good in the in-between times, because you sort of have stuff before and after, and you know sort of the past and the future, and you can kind of guess what happened in between. They're not so good if you try to extend beyond your data, so back into the past or ahead into the future. And unfortunately, ahead into the future is the thing we most want to do. So usually it works okay a little bit ahead into the future. Like let's say you have 40 years of data, you could probably make pretty good predictions about like the next couple of years. But if you want to go like 10, 20, 30 years into the future based off of 40 years of data, the further out you go, the less um, the less accurate you can expect your predictions to be. So basically, you can go sort of a little bit further. And by a little bit, I mean like, look at how much you have, like a small percentage of like the time span that your data covers, like you can go ahead and the prediction should be okay. So this is a real article in a real scientific journal called Obesity. So this is the Obesity Scientific Journal, an article from 2008. And so I'm going to scroll down to the actual article that I'm focusing on here. Where is it? Okay, so this one here. Will all Americans become overweight, obese? Estimating the progression and cost of the U.S. obesity epidemic. So, so these people are like right in the title of their academic article. They're wondering if all Americans will become obese. And so let's read their abstract. Well, maybe not the whole abstract, but basically they're saying they project the future of obesity based on body mass index. So they have data from 1970s to 2004, and they project it into the future to see what will happen to obesity as time moves on. Okay, so they have stuff like here, eventually they conclude that by 2048, all American adults would become overweight or obese. Well, Black women we reach that state by 2034. The prevalence of overweight children would double by 2030. Okay, so they have a bunch of things that they're predicting based on the data we have so far. So let me flip over to my Word document. I actually copied a chart from their article. So these charts basically summarize the data that they looked at. And so the stuff to the left of their dotted line is where they actually have data. So from the 70s up to 2004-ish. And to the left of the dotted line over here for obesity, that's where they have their data. And to the right is just where they've extended their line. So remember I said that your predictions are only good. You can only go like a little bit further than the data you have. So if they have like 30 years worth of data, they should be predicting like a couple years into the future. Instead, they have 30 years worth of data, and they're predicting 100 years into the future. These predictions that they're going ahead here, they're completely useless. So essentially, they're saying like, well, right now it's like 50, 60% of people are overweight and obese. That's just going to keep going up at the same rate, and eventually it's going to hit a peak um, at something like in the 2040s. But even in their graph, they're saying stuff which is completely absurd. Like the women is the lines with circles on it, and the men is the dashed line, and the solid line is all. So right in their graph, like they're saying that all adults will be obese when the solid line hits the top, but the men don't all become obese until some years later. How can we all be obese if some of the men aren't obese? Okay, we can't, obviously, but right in their abstract, they're like drawing conclusions as if that was reasonable. And over on this obesity chart, like somewhere around 2090, all the women are like categorized as obese. But again, like somehow like these other lines don't logically fit up. So they're saying stuff like it doesn't make logical sense because in the real world, so first of all, it's completely absurd that all people could be obese, but not all men are obese. Um, or like these lines, they only make sense if they continue on, right? So like this like solid line can really only be some kind of average if like there's more than 100% of women that are obese. So somehow they acknowledge the fact that you can't go past 100%, but they don't acknowledge the fact that they're doing equally absurd things hitting it 100%. So of course in the real world, these lines wouldn't be straight. They would curve somehow. Like there's going to be some people, it's never going to be 100%. There's always going to be some people who aren't obese. These lines are going to curve. It's not going to be a straight line forever. It's going to be kind of straight like for a while, but when you stand back and look at 100 years, you'll see that it'll curve. And hopefully it'll eventually curve and go down, but you know it has to curve because it, it can't go past 100%, and realistically, it's never going to get completely to 100%. So the point of all of this is that sometimes people just say like, oh, linear regression, I'm going to use this. This is my scientific tool. I'm going to make predictions about it. And then even when their predictions that result say things that are completely absurd, they just sort of keep going and say like, oh, here's what our predictions are. And like if you read that article, and I have read through it, like they do sort of point out that there's problems with the predictions they're saying, but that doesn't stop them from putting it in their abstract and like treating them like they're real conclusions. So the lesson is just sort of be careful, like what's coming out of your tools, and like especially don't do what these people did, which is to take like extend their predictions way beyond where their data is. Okay, so like their data is here, their predictions should be in the in-between spaces or a little bit outside of their data. You can't go like 3 times further out than the data you have. You can't have 25 years of data and then predict 75 years into the future. If you have 25 years of data, maybe you can go like 5 years into the future, and anything beyond that, like who knows? Like there's no reason to assume that the pattern would hold. Things could very well start curving and not follow anything like a straight line anymore. All right, so that's basically it for the course. So for the last couple of days, we'll review and I'll give more details for what I plan for the final exam. Sometime this week, I'm going to try to figure out how to code it into D2L. And once I get it all set up, then I'll tell you like really what I have planned. All right, so that's it for today.